Hey everyone, we're going to start our study of physics with a topic that isn't really a physics topic so much as it is a general science topic, but it turns out that it's crucial to our ability to use physics to understand the world around us. The idea that I'm talking about is a model. Now, what is a model? We'll start with the definition and then we'll go into some examples. A model is just a description of how the world behaves that allows us to make a prediction about how it will behave in the future. Now, you may not realize this, but you're actually using models to understand the world around you each and every day. Let's look at an example. Suppose I'm holding this object in the air. What's going to happen to it if I drop it? Well, of course, it's just going to fall. But crucially, you didn't need to watch it fall in order to know it was going to fall. Your experience with gravity in the everyday tells you what will happen when I drop something. You have an understanding about how the world works that allows you to make a prediction about how the world will work in the future. You've probably never thought of that as modeling, but that's what it is, at least according to our definition. The fact that your model is based on personal experience and not necessarily some deep understanding of how gravity works doesn't make it any less of the model. You understand something about the world, and you can make predictions about how the world will behave. But of course, you're not taking this course so that I can tell you things you already know about the world. You're taking this course because you want to learn something new about the world. So how does physics help us with that? Well, let's go back to the example of dropping this object. You could tell me with complete certainty that when I drop the object, it will fall. But there's a number of things that you probably couldn't tell me. For example, you probably could not tell me exactly how long it would take this object to reach the ground, or how fast it would be traveling when it got there. But physics allows us to answer these kinds of questions. Now, we're not going to study falling objects right now. We'll see them in a few videos. But the crucial thing I want you to take away is the fact that you know how to build models. You do it all the time. All that we're trying to do here is to make those models more precise and quantitative. But why is this interesting for this course? Well, there's really two things that we're trying to learn in physics. The first is just physics, some of the rules by which the universe behaves. But this is not a model. Knowing how the universe works and being able to predict how it will work in the future are not the same thing. So knowing things about physics, knowing facts like conservation of energy, is only really half of the story. To really say that we understand physics, we have to be able to take what we know about it and apply it to a new situation that we haven't seen before. Now, I'm going to claim that the laws of physics that we study are not super challenging. Conservation of energy, which we'll study in the next video, is quite simple at its core. The difficulty comes when trying to use that understanding of the world to make a prediction about how the world will behave. On your exams, you'll be asked to do exactly this. You'll be given a situation and then asked to build a model that describes how that situation will behave. Now, if you have no idea how to do any of this, don't worry. That's what this class is for. But at the end of the day, the best way to get good at building models is just to build models, to practice, just like you would anything else. Now, you will get lots of practice in the various parts of this course. In DL, for example, you will be asked to use things you've already learned about physics in a new situation. You will be asked to apply your knowledge as a model to a situation that you haven't seen before. You will also have plenty of opportunities to practice just by doing practice problems. Now, unfortunately, science is really often taught as a set of rules that we can follow in order to get an answer, or a list of facts that we can memorize. This doesn't really work here. The problems that you'll be given on your exams are problems that you haven't seen before. But crucially, they will never involve physics that you haven't learned. We will never ask you to solve a problem that involves a law of physics that we haven't spent tons of time on in the course. But there isn't really a recipe for building a model for a new situation. But there are a ton of tools that we can use to make it easier, and we'll be looking at those over the next few weeks. I know that the idea of solving a problem like this that you've never seen before might seem a little daunting, but I promise that every single one of you enrolled in this course is capable of learning this. When you're done with physics, you might forget a lot of the really small details or not remember how to do the math to actually get numerical answers. But at the end of the day, I don't really care if a year or two from now you can solve a physics problem on a sheet of paper with math. What we mostly care about is that you're able to go out into the world and see the ways that physics is interacting with your day-to-day life all the time. I'm of the opinion that understanding a little better how the world works makes it a more interesting place to be in, and I hope that by the end of this course, you'll agree with me. That's all for this video. I'll see you in the next one.